Welcome back for another 5 Caillou challenge. This is Tic-Tac-Toe Checker. If we were to set up a tic-tac-toe game, we would want to know whether the board's current state is solved, wouldn't we? Our goal is to create a function that will check that for us. Assume that the board comes in the form of a 3x3 array, where the value is 0 if a spot is empty, a 1 if it is an X, or 2 if it is an O, like so. And you can see how they have 3 arrays here inside of an overall array, and that's sort of what we have going on in the parameter list over here, right? Multi-dimensional array. We've talked about those a bit. We want our function to return -1 if the board is not yet finished and no one has won yet. So there are empty spots, that means. Return 1 if x1, return 2 if o1, and return 0 if it's a cats game, and that's a draw or a tie. You may assume that the board passed in is valid in the context of a game of tic-tac-toe. Good. I think everybody's familiar with tic-tac-toe. You gotta get 3 in a row, but I'll point out in case you're not. So you can win tic-tac-toe if you get 3 in any of the rows of the same symbol, of your symbol. Same for the columns, right? Up and down, and the left, the middle, or the right. And then also the 2 diagonals, that one and that one. So yeah, go ahead and pause the video. This is not too tough of a challenge for 5 Caillou at all. And then come on back when you're ready and we'll get into it. So to solve this, there's only, the way I broke the board down, I just went over the ways you can win, right? And if you counted them, there were 6 of them. There are 3 rows, there are 3 columns, and there are 2 diagonals. So I'm going to make this list of integer arrays, and I'll call it lines. New list int array. Okay, so that's ready to go, right? And the idea is that once I populate this with all the possible lines that you can win in tic-tac-toe, then I will use a looping structure to go through each of these integer arrays and check if all of them are the X symbol or if all of them are the O symbol. I'll also additionally include this flag, a boolean, and we'll call it 0 found. I'll initialize it to false to start. And the idea is that if we find any zeros in the array, we know that the game board is not full. Therefore, this final condition can't be the case, right? Because clearly X and O didn't win. Well, I shouldn't say that just because the zero's present. X or O could have won, but let's say we go through and we determine we didn't find a win for X or O. The finding or knowing if a 0 is present on the board will help us determine whether we should return -1 or 0. The game's deemed a draw when all of the spaces are filled in with a symbol and nobody has won. So that's what I'm doing there. Okay, so let's set up this lines. I'm basically going to have to add each of the rows, columns, and the 2 diagonals. And so to do this, right, and it doesn't really matter how you want to interpret this. This is how the data comes in, right? I kind of just by default, my mind thought, hey, this first one's the top row, this one's the middle row, this one's the bottom row. But you may have thought, hey, this is the left column, the middle column, and the right column. Or it doesn't really matter as long as you get all the combinations. Your checks are going to come out right. So let's make sure we cover everything. So, okay, let's make board, and then let's start with the rows. So I'll say board 0, 0, and then we could say board 1, 0, and board 2, 0. And so that would give me, this should be 0, 0, this should be 1, 0, and this should be 2, 0. Actually, that would mean that these are columns then. But like I said, it doesn't matter. I think I said I thought of them as rows, but I guess when I did that, it made them, it's like columns. But you'll see, as long as you get all the combinations, you're fine, okay? call it row 1 or whatever you want to call it. And so row 2 then, we could say board 0, 1, board, I'm sorry, 1, 1, 1, and board 2, 1, right? That would take this value, and this value, right? The first index is saying which of these arrays to grab from, right? And the second value here is telling you which index of these 3 to grab. So I'll call that row 2, copy it, and then finally row 3, the bottom row, 0, 2, 1, 2, and 2, 2. I'll call that row 3. Now we could start doing the columns. So I'll say 0, 0. Then we'll take, we should take 0, 1. And 0, 2. Right? So it's basically using this whole array right here. So that's saying that's a column. 0, 0, 0, 1, 0, 2. We'll call that column 1. We'll do the same kind of thing for the other 2 columns. So these will naturally be 1, 0, 1, 1, and 1, 2. And then we should have finally the last array, 2, 0, 2, 1, and 2, 2. Good. Let's add a couple more for the diagonals. Diagonal 1, diagonal 2. And so for these we want 1 will be 0, 0, 1 will be 1, 1, and 2, 2. And the other one will be 2, 0, 1, 1, again right through the center, and then 0, 2. That looks right to me. So yeah, whether you interpret these as column or rows is completely up to you. Just make sure, see how I have all the different combinations here. You're going to want something like that. Just make sure you cover all of them. Good. All right, so now I have this lines thing, right? These are all the lines that you can win on in the game. And so the idea is that now I can loop over this collection and do some checks. So I could say for each int array line in lines. Let's define our scope here. And so let's check if the lines contain a string of X's or O's. How would we do that? I can say if line.all. Do you remember the enumerable has an all method, right? So let me bring in system link. Feel free to pull up that doc page if you don't remember that. And it just checks if all elements in a sequence meet a condition. And so let's call my variable name symbol. We're just going to use a lambda here, right? And we know these are integer values, so if you want to use n, you can. I called it symbol because they represent symbols. And so we could say symbol equals 1, right? Remember it said 1 represents X. Here, that's what to return, but up here, 1 if it is an X, and 2 if it is an O. So if line all, meaning all the elements in line are 1, we could say that we found a winner for X, and you can simply return 1. Right? As soon as you find a winning line, you can short circuit like this and just return the answer. You don't need to check the rest of the columns and diagonals and rows if you already found a winner, right? Because as soon as a win happens, the game's over. So good. And as you can imagine, you can basically copy this for the O symbol, which is represented as 2 here. And just make sure you return 2 because that's what they told us to return there. Now, remember that Boolean we set up at the top? We just want to find out, hey, are there any empty spots in here? So provided you didn't have a winner, we can say if line contains, again, another method there that you can look up. That should be with list. List has contains. If line contains the value 0, that's what they told us represents an empty, we can say 0 found equals true. And that's going to help us at the end, because the idea is that we're going through all the lines, and if we hit a winner, great, we return and we're done. But it's very likely there is no winner yet, so we have to handle that final case. And if you recall, it says -1 if it's not finished, so we can say if 0 found, meaning the board's not finished, return -1, otherwise return 0, right? Because if 0 found is false, that means every symbol is filled in, and because we didn't return 1 or 2 here, it means no winner was found. So by definition, if there's no winner and the board's full, you have a cat's game. So I think that should do it. Let me see. I used list here, so we know we need to bring in using system collections generic. Good. Let's go ahead and test this. Make sure I didn't mess up any of those line definitions. Okay, good. We hit green. And green again. So yeah, we must have configured all the lines right. We scan them for wins. If we don't find a win, we basically return whether the board is full or not. And so, yeah, I'll probably submit mine like this. Yeah. And you could have put all these, you could have initialized your list with all these values if you want to. That's fine as well, if you want to refactor that. So yeah, I'll go ahead and submit. Well, let me attempt first. There we go. And submit. Got some good points for that. And yeah, see what you can get from other people. Otherwise, tell me how it went for you. And otherwise, we'll just keep rolling. I'll see you in another challenge. Thanks.